this Zoom land. So again, the AP test, and we'll probably have you take it about the same time, in roughly May, early May. Again, more info will come out about that, but it's just units 1 through 7, which is up to array list. So 2D array won't be on it, inheritance won't be on it, and recursion. We haven't even talked about recursion yet, but we have talked about 2D array and inheritance. You can see there's not all that much more we have to do. Part of unit 7, though, is searching and sorting, and that's what we're getting into. That's what we're going to get into today. All right. So I think, if you're stressed about the AP, and probably all your APs, they're going to be, the idea is that it's only covering content up until like March 1st. So like if it was a year-long class, which most APs will be, it covers just until March 1st. So that gives us some breathing room for sure. We are in very good shape, and I expect you guys to do well on this. And it'll give us lots of time to practice. So this week, I'm thinking we'll see how this Zoom works for you guys. I want your honest feedback afterwards, but I want to cover searching and then sorting data. And those are really the last two big questions I think we haven't really covered very well, or we haven't covered yet. Everything else that will be on the AP is there. So yeah, we have some breathing room, and we can definitely take things a little slower if you like. Okay. But I do want to get to the other topics, because it is part of what you're going to be expected to know, in computer programming, computer science, and I think they're important. Okay. Yeah, does anyone have any questions or thoughts? All right, is your mic working? Seems like it. Did you just say something?
I tried to.
Yeah, we hear you. Okay. We hear you. Great. Okay. So what I wanted to talk about, I know most of you are pretty caught up in things, but I'll just kind of go into last week. So last week was really just getting us settled. There were really 3 activities you guys did, and mostly pretty much on your own. One was used Carlot, which is a good problem about array list that if you have not yet done, I would like you to do. And then there were 2 questions, 2 free response questions about array list. I bet they will be very similar to what will be on the on the real AP that you guys take. So maybe just while I have you here, let's just talk quickly about arrays and array list. So let me pull up Eclipse while it's going on. So I'm going to pull up one student's. So you guys know arrays really well, I think. Array list, it was kind of that last week, which kind of got a little nasty. So array lists are just another way of storing data, right? And the advantage is we don't need to know its size ahead of time. Okay, so if we look at some response here, yeah. So to declare an array list, we use this notation. So array list bracket the type that we want to put in there, give it a name equals new array list bracket the type. So it's really a long declaration that you just kind of have to get used to. All right. So that's declaring an array list. It definitely is longer than an array. But what an array list is really an array that just changes size dynamically. So it changes size as we're using it. And on the AP, they expect you to know how to access elements in an array list. And you'll get this sheet right here, which tells us all of the methods that we need to know, and they give them to us. So list. So for any list, an array list is a list. We have size. So we can access the size. We can add an element at the end. We can add an element at a particular index, and it shifts everything else over. Here's the key one, get. So to get an element, we say dot get parentheses. We don't use those square brackets, right? Those square brackets are just for array. For array list, we use dot get. Okay.
We can't see anything. Are we supposed to be?
You're not seeing my screen?
No.
Oh, shoot. All right. And Xander, you did join us. Nice. I'm sorry. I'm glad you told me. Let's try it again. Okay. So sorry about that, guys. What I was just saying is that these are the methods that you need to know for array list. So again, with an array, we use the bracket notation. So I'll just create a new file real quick. Can you see my screen now?
Yeah.
Excellent. Right. So if we wanted an array of strings, we would say string names. String bracket names equals new string. Right. This should all be old hat to you. And that would be declaring an array size 5 holding, they could hold 5 names, 5 strings in a variable called names. Now, if I want to do it with an array list, we say, array list bracket string. Well, it's just like the, and then we give it, names 2, I'll call it, equals new array list bracket string. So it's long and annoying, but it is more powerful. Okay, so now when I want to use it, I could say names2 dot add Jeff, right? So that's how I add things, or I can add something at a particular location. So if I want to add Xander before that, I say 0, Xander, right? So this is just a quick refresher. We have all of these methods. So with array list, now you have get, set, remove. All great, they're all there. Let's look at what we want to do. So what I wanted to do last week is get a little more practice with it. So it's not it. Where did it go? There it is. So last week I wanted you to do that use car lot, which was a problem that I made up that had an array list of an object, and then 2 from the AP 10-1 and 19-3. Just practice using array lists. All right. This week we're going to talk about searching in arrays and also sorting arrays. Is this time good for you guys? Does 10 a.m. work? Like having every day we'll do 10 a.m. or most days. Maybe we'll skip one or two.
Every day.
Yeah, like 10 a.m. and then that'll like be considered class, and maybe it'll be 3 days of the week. We'll see how things shake out. But could you guys do that?
No, I don't know. Maybe.
Let me see. How do I? I'm trying to see my chat. Why do I not see what everyone else is saying? How about you two?
It works for me.
Okay, good. And if you can't really make it, I'm recording these all, and I will put them all online. So, if you can only make it, say we do it, 4 days a week, you can only make 3. That's not a big deal. Hopefully you can make at least 1 or 2. And then if not, if you don't do it, I'm expecting that you watch the videos and fill out the online form saying any questions that you have, and that's how I will take attendance. Okay. I'm trying to see my chat. Anyone know where I find that? I'm in
More and then chat.
More.
And then chat.
All right. Thank you, sir. Beautiful. I don't know why that disappeared on me. And May and I don't know, who was it? Was it Gianni? Will you just type in if that 10 a.m. generally will work for you? If not, we can find a different time. Okay. All right. All right. Excellent. Okay. So let's plan on that. I guess I'm supposed to go over this. Where did I do with it? I guess I have a link to it. I was supposed to go over expectations of video chat, just so nothing inappropriate happens. So they want us just to go over this document lightning quick. I think they're worried about something inappropriate happening, and yeah. So in a video conference, it's a way to meet in real time. These guidelines will help us align with our community values: safety, respect, responsibility. Okay, you probably will use video chats in your real life. People use them all the time, obviously. I will record any video session, make it to available, so you can ask questions either, in the chat option. I'll keep that up on my screen, or you can just. I mean, it's such a small class, we can just talk them in. And so I will always be appropriately dressed, and I expect the same of you. Curse words, anything hateful, no nudity, of course. If anyone else is around, tell them you're on a video call. Anything that would happen in the classroom, the appropriate behavior of a classroom is the same as the appropriate behavior online. It can help, especially in big groups, to mute your microphone. You'll see a little mute option, when you're not talking. Otherwise, sometimes, there's a lot of ambient noise that you'd be hearing. In the chat, think before you post. Don't, no inside jokes, references to people who aren't in the conversation. Don't get personal. You guys know what's what. Okay, so that's they just wanted me to go over that. Let's go into actual computer science now. Since you're all in on the video chat today, or everybody but Abdi, and he's having some computer issues, I think. Then you don't have to fill out the online form. You only need to fill out the online form if you're not in class. Okay, so I got to add that link for Abdi. I was hoping everyone would be here. And that's your attendance for class. So if you're here, if you're in on the video chat, you don't need to fill out the form. I will mark you present. Otherwise, fill out the form by 4 p.m. I'm supposed to put in attendance at 4 p.m. Okay. And on days when we don't meet, again, that's how attendance is. You need to fill out the form, answer the questions that are there. Right. There may be some homework assignments. We'll see how much we get through today, and we'll go from there. Again, I feel like we have a lot of breathing room now, now that the AP has changed. Xander, so if you just joined us, I'm not sure if you caught the first end of that, but we've covered almost everything that will be on the AP test this year. So we might go a little bit slower, more practice, and most of you guys are taking the AP, so I do want to give you a lot of practice and make sure you ace it. And then
I'm taking the AP, and I have another AP class, so I know about the test.
You've already heard about that?
Yeah.
Yeah. And it's only up to array lists. The things that we're doing this week might be the last things that are new on the that we haven't covered. And then after the AP, I do want to cover all the material in the class. I do want to cover polymorphism, recursion. They're good stuff. We'll work more on that. But it definitely gives us some breathing room if that makes you feel better. Okay. So let's talk about searching in arrays. All right. So super, obviously a super common thing that happens in computer science is you want to find data, right? So what I have here is a program that it's called Lots of Numbers. You could download it if you want. I linked to it for the website today, but I think hopefully we can just look along together. Okay. So in Lots of Numbers, I have a list of numbers. I want to say there's, God, I put in 5 million numbers. Just I filled up a random list of numbers. Okay. I guess I can open it up. I don't know how long that'll take. That's going to kill my computer. Oh, I probably shouldn't have done that. Yeah, that was a bad idea. So it's opening up a list. There it is, of 5 million random numbers that I just had created. Okay. And in array searching, oh boy, I got to close that because that's just going to kill things. I create an array. So we're gonna do this in an array today, maybe an array list tomorrow. Okay. Oh boy, it takes so long. All right, come on, Eclipse. 5 million, it's a lot of numbers. Out of memory occurred. No, I don't want to accept. Okay. Hopefully things will be okay in life. All right. So the idea is I create an array called all nums. My constructor just reads in all the values, and I print out a couple values just for giggle's sake. Okay. So that's what my constructor array searching does. All right. I have a method that sorts it. We'll talk about later. But imagine they're not sorted, and let me hit play and see what happens. Loading the list from the file, and it's going to take a couple of seconds. And it all depends on your computer speed, obviously. But here it is. So this operation, and I record how long it takes to do things. This operation took 7,000 milliseconds, so about 7.2 seconds. Okay, so just reading it in, and then the next method I write is find num, which right now just returns true. Okay, and it looks for some number to check. And if you notice right here, I say, okay, 100 times look for this big old number, and then stop the clock. And so 100 times it does it, and that took 3 seconds just to run. Let's because there's no actual code there, 3 milliseconds, I should say. So I want to find num to check. So I have this big array. How would I find it? How would I find that number? You can chat in your answer, or you can say it out loud. How would I'm looking through the array all nums. I want to find num to check. How would I do it?
In your you'd create a for loop, right?
Yeah, sure. Traditional or for each? What would you like?
I like for each loops.
I do too. So for every int x in all nums. Yeah.
Then you just do like if s or whatever you named it, x.
X, yep.
What is there a get number or s x equals I dot or all nums dot I all nums dot
well, so we're doing a for each loop where x is the number in the array. X will be one of those 5 million numbers that were in that big list. So if x equals what? So x is the number in my big list. If that number is what?
Nums to check. Num to check.
So if that's the case, what I want to do?
Return true.
Yep. And then outside the for loop, right, after I've done everything, what do I return?
False.
And when does that happen?
If it goes through and doesn't return true.
Exactly. If it goes through and doesn't return true. Okay. Now, what is let's hear from someone besides Xander, someone on the text. What is the best case scenario? How many numbers is it going to have to look at in the best case scenario? Somebody tell me, what's the best case scenario? 1. Yeah, that's right, Gianni. And it would be it would only need to check one number if, in the best case scenario, it happened to be the first number in my list, right, in my array. What's the worst case scenario? If there are 5 million numbers to check, what's the worst case scenario? How many numbers is it going to need to look through? All of them. Thank you. Yeah. So, so in the best case, it was only going to take one, but in the worst case, you're going to have to look through 5 million values, right? Which, you know, even on modern computers is not inconsequential. Maybe if you did it once, it's inconsequential, but if you're looking for a lot of things, right, and maybe they're more complicated things, that can be real significant time. So that's not great, right? And just for the record, we in computer science, we always kind of go in with the worst case scenario, right? The worst case scenario is if there are n numbers, we're going to have to look through all n of them. So that's considered big O n time. So the way we say it's the order of operation, like how many values you're going to have to look through is n values, right? But then let's run this now. So now it's going to look for a number 100 times, loads it in. Again, it takes 5, 6, 7 seconds to read it in, depending on your computer. Okay. Now, if you notice, when I did it before, it was only 3 milliseconds because I mean it did nothing, right? It wasn't checking anything. Now it takes 358 milliseconds. Okay, that is something, right? I mean, it may not seem like much, 0.4 of a second, but you could see if we were dealing with billions instead of millions of numbers, then we'd have a problem, right? And even this, maybe we have a problem. So this is it's a stupid way of searching. Can you come up with a better way of searching these numbers? If they're 5 million random numbers in a random order, is there a better way, or do we have to look through every one? Can you come up with a better way of searching?
Are they random numbers?
They're random numbers in a random order. Is there a better way to find a particular number? It's kind of a trick question. No, really, we'd have to, if you had 5 million papers in a random order, right, and you needed to find one particular paper, or you had 5 million names, you're going to need to look over every single one, right? So they're really, and the key thing is if there is no order, right, then we're going to have to look through everything, okay? And that's a problem. So if they were sorted, life would be a lot better, right? So that's what I did. In the next line of my code, I said, all right, let's sort the numbers, all right? We'll talk about how we sort later, but we're just calling a method that sorts them, okay? Now let's assume all those numbers are in order. So I'm gonna play a game here. I'm gonna write a number down. Oh, it's a fun game. Oh, you thought you were getting online for nothing here. I'm gonna write a 3-digit number down. I don't know how you're gonna believe me, but I've written it down. Okay. Now, actually, I see one on my. No, that's fine. All right, I wrote a number down, and we're gonna play a game where you have to guess my number. Okay, and I will tell you if it's higher or lower. Okay, so someone guess what's your first guess? So it's any number from 0 to 1,000, 0 to 9999. So any up to a 3-digit number. Okay, so your first guess is 858. Okay, it's lower than that. I'm gonna lower than 858. Next. Anybody can jump in and make a guess. 345. Higher. So 2 guesses. 512, it's higher. 3 guesses. 720, it's lower. 719, it's lower. Higher. Higher. Lower. Xander's is lower than Xander's, lower than Gianni. Lower. Higher than 69. Lower than 692. It is 691. All right. So that took you, I think, 13 guesses. So if you were an idiot, you could have just said, is it 1, 2, 3, 4, 5, 6, 7, right? And do what's known as a linear search. What you were just doing, the one that Xander wrote, you know, when the numbers weren't sorted, a linear search is as good as anything, right? But what you guys did is, well, you did not have to go through all 1,000 numbers, right? Like the worst case there is not 1,000 numbers. Sometimes people made bad guesses. Like I saw someone said 720 and then they said 719. Probably not the greatest strategy, right? Let's talk about what is the greatest strategy. So if you had, what's the best number to guess at first? So someone, I think Xander guessed 841 for some reason. He was hoping to get lucky. What's the best number? Exactly the middle. Yeah. So let's do that again. Let's see what the worst case scenario would be here. So if you guessed 500, I would have said above, right? 691 is above. What's the next best number to guess at? So 750, okay? And then I would have said below, right? Because 691 is below. Then what's your next best number to guess at? Exactly. So May's seeing the pattern, right? It's the center, it's the middle, it's the average, however you want to call it, of 500 and 750. Okay, so that's 625. That's the middle of those two numbers. That's the center of those two numbers. And I would have said higher. Then what would you have done? Arius, you still with me? Good. All right, so 625 was higher than 625. What's your next best guess? Exactly, 625 and 750, right? And we would keep going through this. And in the worst case scenario, it works out to be like 8 or 9 guesses, right? Not 1,000. Anyone take pre-cal or calculus? Anyone think of what mathematically, if you have n numbers, what's the worst case scenario? How many numbers are you gonna have to look through? Anyone see this is a good question for math people. Anybody see how? Like a 10th, it's a good idea. It's actually a log base 2 of n. So because it's every single time there's half as many numbers to look through, right? So after your first guess, you've eliminated 500 numbers. After your second guess, you've eliminated 250 more, right? So every time there's half as many numbers. So it's oh, I put it in the wrong spot. So big O, the O notation, log base 2, I don't know how to do a subscript of n. That's just for you math people out there, not on the AP, not super important, but just it's much less than linear, obviously, and it's a log function. Anyway, the last thing I want to do today is I want to write that. I want to write find fast. Okay, so let's see if we can write that together. Then we'll call it a day. I want to not go too crazy, and you won't have much work today. I'm going to have, and we'll come back tomorrow, same time, and we're going to do array searching with strings, maybe in an array list. I got a good activity for us. But let's see if we can write this. I want to now all nums is sorted. I want to find it. Does anyone want to think through these steps here? So what did you do first? If there were 1,000 numbers, what was the first number you looked at again?
Exact middle.
Exact middle. So I'm gonna declare a variable that is the middle. What is the middle regardless of our size?
N divided by 2.
What is n though? You're right.
Array list size.
Yes. So the array, it's not an array list though, it's an array. So all nums dot length divided by 2. All right. So we have a variable that's the middle. Okay. We also probably should have our low, our low index, or like, and middle is really the index. Our low is 0, and our high right now is all nums dot length minus 1, right? So we know it's between low and high, inclusive. Let's try middle, okay? So if all nums, if all nums middle, so if the value we're looking at, which is all nums middle, if that's bigger than our number, what does that mean? Number is what we're looking at. I don't like calling it num. Let's see. Num to check. So if all nums middle, so if the 500th thing is bigger than the number we're looking for, what does that mean? Middle equals high. Well, middle equals high. So middle now, it's lower. Yeah, it's on the low side. High equals middle, exactly. So we'll say high equals the middle. Really middle minus 1 if we're being technical about it, because we don't need to check the middle anymore. We can go 1 under, I think. All right. And low doesn't change. What does middle become? So now our high, so if the 500th value is too high, well, our high becomes 499. What's the middle now? What's the middle number that we're going to check?
Could it be 1/4 of all nums?
It would be, but that's going to only work on our first time. That's excellent, Gianni, but we want it to always work. What formula can we do? What would middle be now? Do you remember what May was saying? Like she just said, when I said it was above 625, she said, okay, the middle now is 625 and 750 added up divided by 2, right? She found the middle of those two. So the middle is always going to be the low plus the high divided by 2. Excellent, May. Now, that's one situation. Else, I'm going to just copy this almost. Else, if it is less than the number to check, so if the number we're looking for is less than the number to check, what does that mean then? So if the 500th value is too small, what are we going to change? low equals middle, as May just wrote. Low equals middle, and really I can add 1 because I don't need to look at that one again. What's the other possibility? There's only one other possibility. If the number we're looking at is too high, the number we're looking at is too low, else, what does Goldilocks say? Else.
It is that number.
It is that number. We found it. We can just return true. We found it. Okay. And the middle number is just right. Yay. All right. So, and how many times are we going to repeat this process? Well, we don't know, right? We're going to repeat until either we found the number, meaning we returned, or we've gotten we've gotten to the point where the low and the high are like the same number. If they're the same number, well, you know, or the low is bigger than the high, really, right? If the low gets bigger than the high, we have a problem, right? That means it's not there, because the low always needs to be less than the high. Otherwise, you know, it just doesn't make sense. So it's not a for loop. We're going to do a while loop. So while the low is less than the high, keep doing this whole process over and over. Oh boy. Okay. So while the low is less than the high, well, let's see. Is the number less than it? Is it higher than it? Otherwise, we return true. So it's going to keep doing this over and over again until we return false. That's the general idea. So I know it's way harder to write than linear search, right? Linear search, this one, how easy was this to write, right? But this one, as long as the array is sorted, right? It's going to. Is it always going to be faster? Is this which is known as binary search? Is binary search always faster than linear search? Anybody?
I mean, if the first number was the number you were looking for, then no.
Excellent. But in the worst case scenario, it's better, right? And we really care about the worst case scenario. That's exactly so now let's run this. It loads the list, and we know that takes about 7 seconds. And then it's going to do a linear search, which takes about 0.3 seconds. Oh, I guess we didn't improve that much. So 0.331 milliseconds. And then when we did a binary search, it's 0.25 seconds. So, you know, not a huge difference. It would be a huge difference if we were talking about bigger lists, if we were, if we did this more. But clearly, it's much more efficient, right? That's the idea. I'm going to call a class there. And so what I would like you doing, if you've not already done so, and I know a bunch of you already have, is finish the free responses. Use Carlot, AP 10-1, 19-3. Submit them in the check-in form so I can see them if you've not already done so. And the multiple choice AP questions, if you finish this and have time, do that. There were some questions about this, so if you click on it, you should be able to log in and see the questions. If you have other questions, feel free to email me. Does anyone have any questions today? Again, you're all present for attendance. We're all set there. I'll make this a video available online, and yeah, tomorrow at 10 o'clock, we'll do it again. Nice job, everyone, getting here. Any thoughts, anybody?
So, supposed to under today's class, what are we supposed to do with that?
Maybe, Arias, is that you? Can you type your question? Your voice is very gargled. Or is that Gianni? I don't know who that is, but if you could type it, I can't understand you. Oh, okay. Good question. What's the purpose of the link under the Zoom link? Let's look at the website. So search and arrays, that link is to lots of numbers. That's if you wanted to play around with this in Eclipse, you could import this and try to write your own searches. So that's the code that I had in Eclipse that I just imported. I know it says homework 6 over here. I'll move that out. I'm not going to have that today. I'd like you catching up and just staying with us. Okay, guys? (19.3) confused you. All right, let's. So if you're all set, you can hang up. I'm going to go over 19.3, yeah. So 19.3 was this was last year's AP, and I could see a question being very much like this. So first, they talk about what a delimiter is, okay, and a delimiter might be a parentheses, right, and or in HTML they use like this symbol. So this could be the opening delimiter, and this is the closing delimiter, and everything inside is bold, okay? Then they tell you, all right, there's a class called delimiter, which has these two strings, open delimiter, closed delimiter, and they get set by the constructor, right? And I automatically, my eyes jump to this, to be implemented in part A and to be implemented in part B. All right, in part A, they give you an array of tokens, all right? And you need to return an array list, okay, of delimiters from array tokens. And then they showed us an example. So if this is the opening and closing delimiter, and these are the tokens they give us, they want us to return an array list of these two symbols, this one and this one, right? If this was it, they give us this, we return these three, okay? So the idea is that you're going to do a for loop that goes through all the tokens. If the token is open delimiter or closed delimiter, it is going to add it to your array list. So you're going to, the first step is actually to create a blank array list. Okay, and here's the note to that. So this is how we declare an array list, and then we will add all the tokens that are either open or delete into it. Does that make sense, Sander? That's A.
A little bit.
Okay. And then in B, and I can you know, if you do the best you can and write me, and I can give you the solution, talk it through a little bit more. In B's a little bit more tricky. They want us to write is balanced, which is going to return true if they are balanced and false otherwise. They're balanced if, when traversing the array list from the first to the last, there's no point at which there are more closed delimiters than open delimiters. And in the end, the total number of opens needs to equal closed. So if this is what they gave us, sup, close up, sup, close up, close up. This is true because for every open one, there is a closed one. There's 3 opens and there's 3 closed. And at no point were there more closed than opens, right? So open, open, and it closed it. So these guys are closed. Open, close, and then open, close. And this one is false because there are there's more closed at this point, right? We opened and closed, and then we closed, but there was nothing open, if that makes sense. So they want us to write is balanced, taking in a string of delimiters. Okay, so they're giving us these delimiters, and we need to say is it balanced. So we got to go we just go through our array list using a for each, counting how many opens and how many closed there are in the for loop. And at any point, if there are more closed than opens, we return false. Outside of our for loop, if they're even, we return true. Otherwise, it's not balanced, and we return false. That's a general idea. Okay, so give that a try. Again, homework 6 is not there. Just do any makeup work that you can, and we'll come back again tomorrow. Have yourselves a good day. Feel free to contact me with anything.
You just quickly show me again how a array list is declared.
I would love to. I think I did it right here. So So this is how we would declare an array list of strings called names2. So we say array list string names2 equals new array list string. So that's an empty array list, size 0, and then we can add things to it like I've done. Okay. If you want to see more of that, there is a slideshow about array lists from last week, or maybe the week before, actually, when we were still together. All right, guys. All right, have yourselves a good afternoon. I'll post this video. Bye.
Bye.